Let's see what is a vector. A vector is a magnitude plus a direction. For example, if we have a vector like this, the 5 that you see here, that's the magnitude, and the direction, you can see the arrow of the vector. So now this is what we call a vector, and I'll give you some example of vectors and some example of magnitude. Magnitude, we see the temperature, and a clear definition. Example of magnitude, we see temperature, we see mass, we see volume, and then we see speed. And some example of vectors, we see velocity, displacement, gravity, force, acceleration. And then in terms of formulas, this is how we can represent a two-dimension magnitude, so I can calculate. And this is how you can calculate, we can position the two-dimension vector. And we do know there is an angle in between here, so theta. Okay, let's say for example, let's see what is a scalar multiplication. A scalar multiplication, for example, we got this vector, so it's the same. Let's say we multiply the vector by 2. This is what we call scalar. Scalar, in simple terms, it's just a way to multiply or to our vector, okay, by the same number. Okay, and here it's a representation of 3D matrix x, y, z. This is just a representation of a 3D matrices. And here, this is how you can present the magnitude. Okay. Let's take an example how we can represent this graph. So let me just give you the point x, y. So this is x and that's y. And at this point, if you have to locate this point, let's assume this is 1. Okay, x equal to 3 and y equal to 1. Let's try this one. X equal to 2, y equal to 2. Let's try this one. Okay. Let's represent this point. X equal to -2 and y equal to 2. And this is a 2D representation. Okay. So in short, when you talk about 2D, this is what we see, xy. Then when we cover 3D, it's actually x, y, z. Okay. And if I have to represent it, it could be something like this. So we have x and y. And then when we see 3D, we get something like this. This is where we're going to put x, y, and z. Okay, so negative x, negative, and here negative z. Otherwise, we could even add this is I, this is j, this is I, and this is k. So it's gonna be I, j, something like that. And that means if we have something like this, like we need to locate this point, so it's gonna be x, y, z. So I know y will be negative and x will be negative in this dimension, in this quadrant. Okay, and since this is a 2D, so we're not gonna need z, so it's gonna be something like this. And in this 3D graph, if we have to represent this point here, so we'll have x, y, and negative z. Okay, so this is what you see. That's what I was trying to give you as an idea, and this is a summary of what we just covered. So then